Welcome to Professor Diaries, where knowledge meets purpose. At Professor Diaries, learning goes beyond facts. It's about discovering meaning, understanding life's purpose, and inspiring growth. We bring deep-seated knowledge to life in the most unique and engaging ways, enriching learning for students, parents, and teachers alike. Don't miss out. Like, share, and most importantly, subscribe. Click the icon for the latest updates and help spread the wisdom to others. Brain anatomy, functions, educational implications. Introduction. The human brain is often called the most complex structure in the known universe. It is responsible for everything we think, feel, and do. From ancient philosophy to modern neuroscience, the study of the brain has evolved through history, intertwining science, spirituality, and even cosmic chemistry. In this video, we will deeply explore the 7 key parts of the brain, their history, principles, chemical composition, biological functions, interrelations, merits, demerits, and even their connections to artificial intelligence, astrochemistry, and education. Furthermore, we will analyze how these brain regions impact student learning, cognitive development, and academic success. We'll also suggest learning outcomes, educational objectives, and ways to improve cognitive function for better academic performance. Let's embark on this fascinating journey into the mind's architecture. The frontal lobe, the seat of conscious decision-making history background. The frontal lobe has been studied for centuries, but a major breakthrough came in the 19th century with the case of Phineas Gage, a railroad worker who survived a metal rod passing through his frontal lobe. His personality drastically changed, revealing the role of this brain region in personality, reasoning, and self-control. Ancient Greek philosophers like Plato and Aristotle speculated about rational thought originating from the brain, while modern fMRI scans confirm the frontal lobe's role in decision-making, planning, and social behavior. Principles, assumptions. The frontal lobe is the center of logical reasoning and future planning. It allows impulse control and plays a vital role in shaping personality. It is highly evolved in humans, distinguishing us from other species. Chemical biological composition. Neurotransmitters. Dopamine controls motivation and reward. Serotonin regulates mood and decision-making. Glutamate, essential for cognition and learning. Biological components, made up of billions of pyramidal neurons connected through synapses. Merits, functions. Enables logical thinking and problem-solving controls, emotions and impulses. Essential for creativity and intelligence. Demerits or limitations. Damage can lead to emotional instability and poor decision-making. Overactivity may contribute to anxiety and overthinking. Educational implications. The frontal lobe plays a crucial role in critical thinking, decision-making, and problem-solving. Students can improve their focus, planning skills, and logical reasoning by engaging in structured activities. How students can improve learning. Engage in problem-solving exercises like puzzles, debates, and logic games. Practice mindfulness and impulse control through meditation. Develop strategic thinking by playing chess and similar games. Learning outcomes objectives. Outcome: enhanced decision-making, analytical thinking, and problem-solving. Objective: students will be able to approach challenges logically and make rational decisions in academic settings. 2. The parietal lobe, the bridge between senses and perception history background. First recognized in the 1600s, when anatomists noticed its role in sensory perception. Research in neurology and brain lesions helped establish its link to spatial awareness and body coordination. Principles, assumptions. Acts as a bridge between touch, spatial awareness, and movement. Helps integrate sensory input from the body. Essential for mathematical thinking and abstract reasoning. Chemical biological composition. Neurotransmitters. Acetylcholine, responsible for attention and sensory integration. GABA, inhibitory function, preventing sensory overload. Merits, functions. Helps us recognize shapes, objects, and numbers. Essential for hand-eye coordination and mathematical thinking. Demerits or limitations. Damage can lead to loss of body awareness, e.g., not recognizing one's own limbs. Can cause difficulty in reading and solving mathematical problems. Educational implications. Improves spatial reasoning, numerical skills, and coordination. Essential for STEM, science, technology, engineering, and mathematics, subjects. How students can improve learning. Engage in activities like drawing, puzzles, and building blocks. Practice visualization techniques for math and physics. Play sports to enhance spatial awareness. Learning outcomes. Objectives. Outcome. Improved mathematical ability and spatial reasoning. Objective. Students will develop better problem-solving skills in geometry and physics. 3. The occipital lobe, the brain's vision center. Functions educational implications, processes visual input from the eyes, enhances reading and image recognition skills. Essential for students who rely on visual learning. How students can improve learning. Use visual aids like diagrams, charts, and videos. Practice mindfulness exercises to reduce visual stress. Engage in artistic activities to stimulate creativity. Learning outcomes. Objectives. Outcome. Improved reading comprehension and visual recognition. Objective. Students will retain more information through visual learning strategies. 4. The temporal lobe, memory emotion processor functions. Educational implications. Essential for auditory processing and memory formation. Vital for students who learn through listening, auditory learners. How students can improve learning. Use mnemonics, storytelling, and repetition to enhance memory. Listen to audiobooks and educational podcasts. Learning outcomes. Objectives. Outcome. Stronger memory retention and auditory processing. Objective. Students will improve their ability to recall information during exams. 5. The cerebellum, the coordinator of movement, controls motor function and reflexes. Essential for students in sports and physical education. How students can improve learning. Engage in physical activities like yoga, sports, and dance to improve motor skills. 6. The brainstem, the gateway between body-mind. Regulates heart rate, breathing, and consciousness. Helps students manage stress and relaxation techniques. How students can improve learning. Practice deep breathing and meditation for focus and stress relief. CHA. The corpus callosum, the bridge between left-right brain. Facilitates communication between brain hemispheres. Balances logical and creative thinking. How students can improve learning. Engage in both artistic and logical activities to strengthen connections. Conclusion. The brain is not just an organ, it's a living cosmos within us. By understanding its structure and functions, we can improve education, boost cognitive abilities, and enhance learning outcomes. The integration of brain anatomy, artificial intelligence, quantum physics, and astrochemistry. Introduction. The human brain is a biological marvel. And as we advance in science and technology, we find intriguing parallels between neuroscience, artificial intelligence, AI, quantum physics, and astrochemistry. In this extended exploration, we will integrate the anatomy of the brain with 1. Artificial intelligence, AI. Can AI mimic brain functions? 2. Quantum physics. Consciousness. Is the brain a quantum processor? 3. Astrochemistry. Cosmic influence. How does cosmic energy affect cognition? 4. Philosophical chemistry. The role of chemical evolution in thought processes. 5. Chemical composition of the brain. Can we manipulate it to enhance intelligence? 1. The brain and artificial intelligence. AI. Brain functions and their AI counterparts. Each part of the brain has a corresponding AI function. Can AI mimic the brain? AI is inspired by neural networks, but it still lacks true consciousness and creativity. Neuroprosthetics BCIs, brain-computer interfaces, are developing ways to connect AI directly to human cognition. Educational relevance. AI-assisted learning can adapt teaching methods based on a student's cognitive patterns. Brain-AI interfaces may enhance memory and reasoning skills. 2. The quantum brain hypothesis. Can the brain work like a quantum processor? The human brain might operate at a quantum level, similar to superposition and entanglement in quantum physics. Microtubules and neurons may play a role in quantum information processing. Orchestrated objective reduction theory by Roger Penrose. Quantum physics and thought processing, educational implications. If thoughts are quantum-based, learning techniques can be optimized using quantum models of cognition. Meditation and altered states of consciousness might increase cognitive efficiency. 3. Astrochemistry, the cosmic brain. How does space affect brain chemistry? Cosmic rays, solar radiation, and electromagnetic waves influence neuronal function. Astronaut studies show that deep space alters cognition and brain plasticity. Interconnection between brain chemistry and space educational implications. Understanding space chemistry and its effect on consciousness could lead to advancements in cognitive enhancement. Could space-based frequencies be used for brain therapy? 4. Philosophical chemistry. The evolution of consciousness. Chemical basis of thought. Neurotransmitters like serotonin and dopamine govern emotions. Ancient philosophers linked chemistry to spiritual states, alchemy as early neurochemistry. Could thought itself be a chemical reaction? Brain function is electrochemical, meaning our very perception of reality is shaped by chemical states. Educational relevance. Understanding chemical mind states helps in stress management, memory enhancement, and emotional intelligence training. 5. Chemical composition of the brain and cognitive enhancement. Major chemicals in the brain. Can we enhance intelligence through chemistry? Nootropics and smart drugs, e.g., caffeine, modafinil, enhance cognitive function. Diet brain health. Foods rich in omega-3, antioxidants, and amino acids improve learning capacity. Educational implications. Neurochemical optimization through diet and lifestyle can enhance memory and focus in students. AI-powered brainwave stimulation, like binaural beats, may improve learning. Final educational outcomes. How to apply this knowledge for students and educators. Enhance memory and learning with cognitive-boosting strategies, diet, meditation, and AI tools. Use AI-driven tutoring for personalized education. Explore quantum cognition to develop multidimensional thinking skills. Apply neuroplasticity principles to improve learning through repetition and visualization. Understand space's impact on the brain for better astronaut training and mental resilience. The future of human intelligence. The brain is not just an organ, it is a biological AI, a quantum processor, and a cosmic receptor of universal frequencies. As we move forward, AI will merge with neuroscience, enabling direct brain-AI interactions. Quantum brain research may reveal how consciousness arises from fundamental physics. Astrochemistry will help us understand the impact of the universe on cognition. Final thought: if we master brain chemistry, AI, and quantum learning, we may one day unlock new dimensions of intelligence, creativity, and interstellar thought processing. Are we ready to evolve into an advanced cosmic species with AI-enhanced intelligence? Join us on this journey of knowledge, wisdom, and discovery, where learning knows no limits and ignites the soul. Stay curious, stay inspired. If you found value in this, like, share, and most importantly, subscribe to Professor Diaries. Hit the icon for the latest updates and help spread this wisdom to others. This is Professor Diaries, signing off. Until next time, keep learning, keep growing.